Good afternoon. My name is Tania del Giudice. I work with Stefania Magri and Mauro Quagliati at ARPAL on marine modeling issues. ARPAL is the regional agency for environmental protection of Ligurian region, and main activities are related to the monitoring of the environment and the control of potential sources of pollution of several themes. In ARPAL is also there is also the meteorological and hydrological center of civil protection that carries on the weather daily forecast for the region, and also the river level monitoring. ARPAL has a long experience also in marine activities concerning the environmental control of the marine, of the sea, and especially in chemical analysis of water sediments, on habitats such as Posidonia oceanica or macroalgae on rocky bottom. ARPAL is also in charge of the control of the bathing water quality, and carries on also the monitoring of the toxic algal blooms such as the Ostreopsis ovata. ARPAL, you know, is also the reference agency of the Marine Strategy Monitoring Program that began on July of this year, and is the reference agency for the North Mediterranean area. The amount of work on sea and on marine data underlined the necessity of having a tool of forecast in an operational mode to assess the marine environment. On this base, in the last years, ARPAL had the operational hydrodynamic model of the Ligurian Sea that has been developed by DHI Italia with the Mach 3 package. Of course, this model is based on Copernicus program data, and consists in a downscaling of the MFS 3D model of the Mediterranean Sea. The downscaling goes from 6.5 kilometers of resolution from the boundary conditions to up to the 500 meters along the Ligurian coast. The meteorological forcing is based on the Moloch LAM model, and also river discharge are taken into account based on the drift hydrological model. This gave rise to the hydrodynamic operative model of the Ligurian Sea that is operative in ARPAL since September of 2013. The output consists on maps of current, temperature, and salinity at different levels of depth. And the model simulates the 48 hours. This hydrodynamic model gave to ARPAL the opportunity to participate to a cross-border project, the SICOMAR 1. Among the partners, there is also LAMMA consortium that is here with us. The aim of this project was to build up a sustainable system with a lot of investments of innovative technologies for data collection and for long-term monitoring. Among these, there are radars, wave gliders, and ferry boxes. among the actions of ARPAL, there was the develop of several models of last mile, and the use of the data coming from the sampling of the ferry boxes for the calibration and the validation of this hydrodynamic model. This project gives us the opportunity of underlining that the integration between the knowledge and the data is very important. So all this data coming from the ferry boxes from other instrumentations and from data collected from the ARPAL buoys, such the ones in Capomele, on Portofino, and also from the environmental monitoring, must be collected all together in a view of sharing all. That is the reason why we are here, I think. So we know that this is a key issue for the model community, not only the marine one. So we know that the better data we have, the more realistic will be the phenomena that we have to simulate. So the open data will give us the opportunity to have management, a better management of emergency, or a calibration and validation of models that we have, a safer navigation, and the sustainability of investments. The hydrodynamical model is going further into validation and calibration, and is also a very solid base for several tools that we use in ARPAL, such the oil spill one, the sediment and the mud transport, the search and rescue, and the bathing water quality, of which I let Stefania talk about. Thank you.
Good afternoon. So now I'll talk a little bit more about the bathing water quality application that we developed. This application was developed starting from the hydrodynamic model that was now described. In order to properly simulate the phenomena of spreading and decay of bacteria, it was necessary, though, to make a further downscale of the model. So a focus area that we can see here in the picture that includes the coastal area of the city of Genova and the Tigullio Bay, and also you see the marine protected area of Portofino, was considered for a further downscaling. This downscaling reaches a resolution up to 50 meters along the coast. So the hydrodynamic model was then coupled with a water quality model, Ecolab, by DHI. The Bathing Water Quality Directive indicates two indicators for water quality contamination that are Escherichia coli and Enterococci. The model can represent and simulate the spreading of these bacteria and their decay in time. The goal of this model is to have a tool to predict the potential biological contamination, especially from the river. What we want to reach is a tool that tells us whether the hydrological predicted condition can trigger a critical situation in the coastal area, and which area is interested by the contamination and for how long. In fact, we all experience that during rainstorm, the water quality along the sea decreases. This is because the river itself is a source of contaminants, because it contains naturally organics and bacteria, but also because during rain time, it collects contaminants, for example, from the runoff, or also because during rain time, it is possible that domestic sewage system works with the overflow bypass the system. And it can be discharged directly in the river or directly in the sea. So the model considered these two sources of contaminants. The flow rate is considered as input from the hydrological model drift. This model uses as precipitation input both the forecasted precipitation and the observed data. While the load of contaminants was found through a correlation found through a specific sampling campaign in a study area. We can see in the picture the study area. This is an area in the city of Genoa. It's a very highly and densely populated area. We can see there are many creeks interested in the area. The lines that we see are the sewage system. And in time, we have seen that the area shown some short-term critical problem of water quality. So the triangles that are shown in the map show the sampling points. And the samples were taken along the river, at the river mouth and in the sea. The sampling were taken in dry condition and a different rain condition in order to get the correlation between the concentration of bacteria in the river and the flow rate. So the concentration of the bacteria was found for both type of bacteria, Escherichia coli and Enterococci, and is correlated to a reference value of draw condition and the flow rate. The model gets the input data and combines the advection dispersion model, so the hydrodynamic condition, with the biological and chemical processes. The Ecolab model simulates the bacteria decay rates in the seawater. What is important is that the decay rate depends on physical parameters that are given from the hydrodynamic model. For example, salinity and temperature comes from the hydrodynamic model, while the solar radiation comes from the atmospheric model. This is an example of the model application. This map shows the results of a sampling campaign done in April 28th of this year in the morning. The dots represent the sampling points and the color represent the concentration. The red color, I'm not sure you can see, yes, represent the threshold, the limit defined by law from bathing water quality. What we can notice is that the black concentration that is the highest, is very high, was found in the river, along the river. This is the result of the simulation run by the model. The model has a run that goes for 48 hours. So what we see now is a simulation from April 27, 12 UTC, till April 29, 12 UTC. We can see, as time goes by, the spreading of concentration and the decay of concentration of bacteria. The model simulates both bacteria, even though here I'm showing only Escherichia coli. So if we compare the results of the model at about 10 a.m. in the morning, that is when we took the samples, with the results of the samples, we can see, using the same color scale, of course, that the model gives us some pretty good indications, some pretty good values for the Sturla Creek, that is this creek, while it doesn't give a very good indication for the Priaruggia Creek, that is smaller. Also, one thing I have to say that even though the sampling were taken only for these two creeks, then the result of the correlation was applied to all the creeks in the area, referring to the area of the basin. So we can say from our experience that the numerical modeling represents an important tool for environmental study because it integrates and compensates the limits of punctual sampling. Of course, a natural phenomena can be good represented if we have reliable data and dense in time and space. And this is why it is very important to use all available data that we can to validate and calibrate the model. And finally, if we reach a reliable model, then it can be a very powerful tool for decision makers. And that's it. Thank you.